Docker Swarm. And since we learned about load balancing yesterday, we saw how you could balance the load between different containers in different worker nodes. So we understood that there can be so many different containers running in different computers, which we call them worker nodes, and rendering one and the same service, which is a unanimous service to the client. So that is an aspect of load balancing. So if they ask you to explain load balancing with respect to Docker Swarm, I'm sure you can explain how different containers can be running in different EC2 instances or in different environments, but offering the same service. Okay, that is load balancing. That means it is balancing the load of all the containers. Now we are going to see what is scaling of containers. That is what we are going to see today. How do we scale containers? Scaling them up and scaling them down, which means that what if we decide to start with 5 containers, and we at one moment want to move to 10 containers. How can we do it? Right? If we start with 5 containers and we are moving to 10 containers, how can we do it? And if we move to 10 containers and at one particular moment we want to come down to 5 or 6 containers, how can we do it? So that is what we are going to be talking about, scaling of containers. Then the next thing we are going to be looking at is performing updates. How are updates performed in Docker Swarm? What are updates first of all, and how are those updates performed? We are going to look at that. And then we are going to look at handling failovers. What are scenarios of failovers? What are the various scenarios where things can go bad and we experience failovers? We are talking about rollback here. How is rollback performed in Docker Swarm? All right. Then we are going to see how you can continuously add or remove container nodes from the service. When we talk about adding nodes from the service, it's just like joining. We know how to add more nodes or more worker nodes to the master, and we understand that we can once we install the master, we can take another node and then we just add, and it becomes in the service. Okay, this is what we have today. So right, what I was doing before the class actually began, I was trying to configure the service, and this is a service that is running. We have the master here. Look at what we have up here. The master is here, then this is worker 1 and this is worker 2. I've just configured the master and I have not yet joined this worker to this master and this worker to this master. I've not yet joined them. So let us join the workers to the master. We copy our linkage and then we execute it in worker 1. We make sure that it is joined. We also execute it in worker 2. There is some sort of an error. Let's see if Docker is probably installed -- version. Yeah, Docker is installed. Let me check. Okay, this one has joined without any problem, but this one, the error says that what? Error response from daemon. Yes, Declan, your hand is up.
So it's like the recording is not on. I do not see.
Have you seen that it's on?
Okay, okay.
Yes, Adija.
So please, the writings are small. I'm not seeing.
You're not seeing the writings.
Yes, sir.
Did, did you follow the class of yesterday, Adija?
You actually sent the class this morning, but I wasn't at home to download it. So I'll download it after the class.
Okay. So why is our worker 1 having a problem accessing our node? Okay, let me relaunch it. Worker 1 is okay. So why is it refusing? Let us try to decipher why our worker 1 is not joining. Now we come to our worker 1 is having no route to host. Our worker 1 is having a problem with the host. Oh, that means Docker is not. Okay, let us kill worker 1 and set up another node. I hope you understand what is happening here. So we give it some time for it to come back. Our worker, our node master 1 is ready, and our worker 2 is ready. It has already joined. This node has already joined. So if we come to master and we say docker node ls, you see we have a worker 2 that is ready here, and we have a master that is ready. So let us see if our worker 1 can join. Okay, now I think our docker is installed. All right, let us try to see if we can join the master. Okay, we successfully joined the master. So let us see now from the master, docker node ls. Okay, we have now master, worker 1 and worker 2. So our cluster is ready, and it is all of them are active. You see the master is called the leader here. Okay, all of them are active. So what are we trying to study today? We are trying to study scaling of containers. That means we have a situation where we had before in this setup like this. In this setup, we had before say 5 containers, where there is 1 here, there is 2, there is 3, there is 4, there is 5. We have this situation, and then after we might decide that we want to scale to maybe 10 containers. We have another one, another one, another one, another one, and then another one. So we have scaled up, and we want a situation where after scaling up we could also scale down like this. We delete containers, delete containers, delete containers, and have just this. So we can either go with scaling up or scaling down. That means if we want to increase the containers, we can increase the containers, and if we want to delete the containers, we can delete the containers. This is what we call scaling up and scaling down. Okay, so in order to practice scaling up and scaling down, let us launch Nginx. Let us start Nginx with 5 replicas. Okay, this is a command for us starting Nginx with 5 replicas. Remember that you always execute everything from the master. So we know, we already know this command, docker service. In the docker service, we do not say docker run, we say docker service, and we say create. Okay, not docker run. Hyphen name. Our name of our container is app server, and that container we are going to map it to 8080. We want 5 replicas of that container. Okay, and the container name, the image is Nginx. All right, that is what we are launching. Okay, our containers are ready and running, which means if we want to see all our containers, we can see them and see exactly where they are running. Okay, in order to see our containers, that is the command docker service ps. All right, when you run docker service ps, you are going to see all your containers. This is app server 1, first container, second container, third container, fourth container, fifth container, and worker 1 is having how many containers? 2 containers, and worker 2 is also having 2 containers. Then the master is having only 1 container. Okay, so this is our caricature that is there. Okay, and we can use any of the public IPs to get into Nginx. Any one of them, we can use it and we will get into Nginx. Okay, just like we said, if you use any public IP, you can even start from worker 1, and you will still get into Nginx. We say we did a port binding to what? To 8080. So we go to 8080. So our Nginx is up and running from any port, whether it's port worker 1, worker 2, or worker 3. You will see this Nginx up and active. Now, after having done that, we want to increase Nginx to 10 servers. All right, just like what we said, we want to increase this to 10. like this. We want to have this caricature. So what is the command for us to run? Here is the command that we can run to increase. Docker service scale. That's what we are going to use in order to increase. We are scaling what? You are scaling the name of your container equal to the number of replicas that you want to be increased. They were first of all 5. Now you want to increase to 10. So you run this command, docker service scale app server equal 10, and you always run the commands in the master. So our application have scaled, and we need to see how many containers that are now running. Okay, we still run our very command, docker service ps app server. You see our containers are now 10 of them. We have left from 5 containers to 10 containers. Okay, that is what we call scaling of containers. So in this type of a situation now, if you have a situation where there is too much traffic entering your containers, you just need to come and do this, and your application will scale up and become highly available. All right, now in a situation where traffic has reduced and you see that there is much reduction now, and traffic is no more flowing like it was flowing before. Traffic is no more flowing like it was flowing before. What you can do is you can scale down. Okay, how do you scale down? You still use the same command, docker service scale. Now in this time you are scaling down maybe to 2 containers, app server equal 2. So all you need to understand is your commands, docker service scale app server equal 2. You run that command, run everything in master. You see, other containers must have been destroyed, and if we check what is happening now, are we going to see 2 containers running? Of course, we are going to see just 2 containers running. Remember that we are not doing anything in the workers, just 1 and 2 containers are running. This is what we have with respect to scaling. So when anybody asks you that what is scaling in Docker Swarm, you tell the person you already know what scaling is all about in Docker Swarm. We are increasing the number of containers, or we are decreasing the number of containers in different various worker nodes. Okay, that is scaling and scaling up and scaling down. Now let us look at performing rolling updates. Okay, performing rolling update. In order to perform rolling update, what is rolling update and how is it performed, and what type of a scenario will make us talk about rolling update? It is a very important concept when it comes to IT and all this DevOps stuff. Now remember that applications are always updated. Remember that some services are always updated. When I talk about updates, what do I mean? Take for example, we started with version 1, and we had to patch 1 or 2 things, and we are moving up to version 2, or we had to do 1 or 2 things and we are moving now up to version 3, or our dependencies needs to be updated. For example, your application was running under Java 8, and now Java has said that it is no more supporting 8. It is now allowing support for 8, and everybody should migrate to Java 11. What will you do? If your application was running on Java 8, you will need to update from Java 8 to Java 11. That means you are updating your dependency. The dependency of your application has to be updated from the lower dependency to the upper dependency. Now take a look at this. Imagine a situation in which you have all this application, and the underlying daemon behind the application is Docker 20.4. What is our version here? That's the version of our Docker. Let's see, Docker version. Now this is the latest version, which is 24.0.6, right? Now imagine that you had an application that was running Docker, and the Docker version was, instead of 24, the Docker version was about 21.0.5. that is your version. Now Docker releases a statement and saying that everybody that is having Docker that is below 23, Docker will no more be supporting that application or that particular version. Everybody has now to update from 21 to 24 or 25 at least. So what will you do? You have to update your containers. All these containers will have to get updated, or this node will have to get updated. There is a special way for updating nodes. There is a special way for updating containers. In the case of updating nodes, what you do is you drain all the containers. All these containers can move to this tool while you update this node. Then the containers come back, you update this one. The containers come back, you update this one. That's what you can do with that at that level. But in the case of containers, what will you do? You are going to do what we call, you are going to perform what we call rolling updates. What is rolling updates? What do we mean by rolling updates? Now, with regards to what rolling update is, imagine that you have let's take it this way. Imagine that you have 1, 2, 3, 4, 5 containers, right? These 5 containers have to be updated from 1.2 to 1.7. Now, all these 5 containers cannot at the same time just get updated at that particular moment. What will happen? The system is going to block. The system will no more be existing while the containers are updating. There will be no more traffic that is entering the system. Why? Because all the systems are updating at the same time. But now, imagine a situation where you don't want to block the whole system. What you want to do is you want to block just one container. Now, you block this container and then you update the container. After you finish updating the container, all these other ones are giving service. Service is available. There is no stoppage of time. This container is updating. Then after this container finish updating, what do? You block this other one. And when you block this one, what happens? This one has already updated. These other ones are available. This is the newest one. This one like this is the newest one. These ones are old ones, right? So the combination of new one and old ones will still be rendering service while only one is undergoing the process. Okay, so this is what we call rolling update. This one updates and gets finished. This one updates and gets finished. This one updates and gets finished. This one updates and gets finished, and then this one also updates. That is, they are updating in a round robin manner, in a rolling way. This one updates, finish, the other one takes an update and roll over, and this one updates and roll over. That is what we call rolling updates. Okay, so in order to perform this rolling updates, what are we going to do? We are going to run, let us run CentOS. Are we going to run CentOS? No. Let us run the Redis container. Now, let us create a Redis version 3. Okay, let us create a Redis version 3. After we create a Redis version 3 with how many replicas? With 6 replicas. We create Redis version 3, and that version 3 is going to have 6. Redis is an application, please. We create with version 3, and after we are going to update from version 3 to version 4. Okay, we'll update from version 3 to version 4. When we update from version 3 to version 4, we'll see how the rolling updates are going to take place. So let us run Redis. So what are we having now? We are having Redis version 4, version 3. Excuse me, we are having Redis version 3 deployed. Okay. Now, after we have deployed Redis version 3, now we want to update from version 3 to version 4. Okay. In order to update from version 3 to version 4, okay, let us check the replicas. We did not check the replicas, where they are and how they are doing. So these are the replicas of Redis. There are 6 of them, right? We had 1, 2, 3, 4, 5, 6. Okay, and in the right manner, they are deployed 2 in each node. 2 in master, there is a master and there is a master. 2 in worker 2 and 2 in worker 1. There are 6 of them. So all of them are deployed equally in all the various nodes. Okay, now we want to update Redis. Okay, we want to update Redis from version 3 to version 4. So this is our command to update Docker service update -- image. We are updating this image to Redis 4. Okay, let us run it and we see. Okay, look at the rolling update. Are you seeing that this one starts running, gets finished, this one takes over, running, gets finished, this one takes over, is preparing? That is occurring in a rolling manner. Okay, each and every one goes on in a rolling manner before it finally gets finished. So the version now that we are running now is version 4. Okay, at the beginning we were running version 3. Now we are running version 4. It has updated in a rolling way. If this Redis, if it is running a service, you that is using the service, you will not even see that people are working in the background. You won't see that people are working in the background because the service will not be available, will never cease from being available to you. The service will always be available to you at all the times. Okay, now in a case where there is a problem, you know, there is never a time where you totally do an update and everything works very well. We have updated to version 4, but we could have a problem. And if we have a problem with that version 4, things are not moving on well, some commands are broken, things are not moving the way we had it in version 3, and the manager says, look, you guys know what, just bring back the old version, let this new version go back to the lab, bring that back, the old version. So you have to roll back, you have to do what we call roll back. Okay, in this case you are going to downgrade the Redis to version 3, and the command is simple. That is your command, Docker service update, and what you come with it is roll back. You don't need to precise that version 3. Once you say roll back, it knows where it came from before it rolled, it updated. So once you say roll back, it will go automatically back to that version where it was coming from. So if you make rollback, it is going back to the previous version, which is version 3. Okay, so here is it starting. Look at where it is beginning from down and going up. When we said update, it started from up and it was coming down, right? So rolling back to the initial version that was available. Okay, so that is how you can use Docker Swarm to manipulate your application. You deploy latest version. You can redeploy back old versions. Okay, you can do your load balancing with it. Okay, that is the level of the application. Now, if you decide that you don't want this particular node to become part of this cluster, maybe you don't want node worker 1 or let's say worker 2 to be part of this cluster. How will you do? How can I decide that worker 2 is no more part of the cluster? Remember, before we remove any node, count the number of nodes that are there before we start removing nodes, so that you should be very very observant. Now look at, we have this one has been rolled back. Okay, we have these various nodes that are there. There are 6 nodes in total, but this one is simply telling you that the node was rolled back from this one to this one. Okay, but there are 6 of them in total. Okay, so we want to eliminate one of the nodes. In order to eliminate one of the nodes, let's see our command. We have a command that we need to run in order to eliminate a node. Okay, there are 2 ways of eliminating a node. In the first way, we say that the node can be drained. Node can get drained. And in the second one, we say that the node can leave. Okay, it is either you drain the node or the node leaves. So how can you drain a node, or how can the node leave? Let us see. The first way is draining the node. Manager can drain the node. Okay, that means from the control plane in the manager, you can decide and drain a particular node. Okay, what is the command for draining that node? What is the command for draining the node? We have the command here. First of all, let us look at list of all our nodes. We know that we have 3 nodes. Let us be confident that we have 3 nodes. Here are our nodes: master, worker 1, worker 2. Okay, so let us drain one of the nodes. Docker node update -- availability drain worker 1. Docker node update -- availability drain worker 1. This is how you can drain a node. Okay, so we are draining it from the master. Remember, from the master. So when we run our command, what are we saying? Docker node update drain worker 1. Error response from daemon, node worker 1 not found. How is our worker 1 spelled? In capital letters, I guess. Good. So you make sure that you respect the caps. So worker 1 has been drained. So when worker 1 is drained now, let us look at how many nodes are there now. We have only master is there, worker 2 is there, and worker 1 is showing that it is drained. Okay, it is showing that it is drained. That means it is no more part of this cluster. It is not active. It has been drained. Okay, it is not active. So having drained worker 1, question is, where are all those containers that we are in worker 1? What happened to all the containers that we are in worker 1? So let us see what happens to all the containers. Now for app server, our app server, which was our Nginx, we can see that worker 1 shut down and we had two containers. So since worker 1 shut down, the two now are running but in master and worker 2. Okay, the two containers that were one of the container was in worker 1, it is now in master, and the other one is in worker 2. So let us check on Redis. What about Redis? Redis had almost close to 6 containers. So let us check on Redis. Okay, for Redis, let us see. All right. Now we have drained worker 1. Everything under worker 1 is shut down. Everything. Now let us count. We had altogether 6 nodes, 6 containers, right? So take a look at this. When you see this one coming down, that means it is a, it is a copy. Okay, this one was formally updated. So you count this one. Master is running 1. Okay, master again is running the second one. Okay, worker 1 is running, no, worker 1 is shutting down. All of it is shutting down. What is running is worker 2. Worker 2 is running this one, and worker 2 again is running this one. That is 4, right? Now this one is shut down. Master is running this one. That is 4, and worker 2 is running this one. That is 5, and worker 2 again is running this one. That is 6. So all the nodes that were in worker 1 are now being redistributed to both master and worker 2. Okay, because node worker 1 has been drained. Okay, now that is the first method by which we can drain, actually remove a node from a service. The second one is nodes themselves can leave. When you talk about master draining, remember that we ran the command but in master and the node was eliminated. That is master draining. Now if we run the command but in the node and the node is eliminated, then it means that the node has left the cluster. Okay, the node leaves the cluster. All right, in this type of situation, we can run the command docker swarm leave, and we are running this command now but in node, the particular node that we want that it should leave. So we have the first one is master drains the node, and the second one is node can leave themselves. Those are the two ways by which you can remove nodes from your cluster. Okay, so in this one we have to come back to worker 2 and then we run the command there. You see, that's it. Node left the swarm. Node left the swarm. Okay, let's come now to our master and then we run docker node ls. You see, this one is down. Okay, and then this one is drained. This one is down and this one is drained. Okay, so worker 1 and worker 2 are no more there. They are no more part of the cluster. Okay, give it some time and all of them will totally, this one will no more be active. Okay, so that is how you remove and add extra EC2 instances. Is there any question, please? Is anybody having any question? Okay. The lack of no question, I believe, means that we are understanding very, very well. Not that we are totally frustrated and don't know what to ask.
So it is well understood. For me, I'm not saying for others, so understood, sir.
All right. Okay, remember that in order to create a swarm, what did we do? We just installed Docker inside all the machines and then we made one machine the master, right? Is it possible to make the other machines too to be masters? Can it happen that instead of making one machine master, we exchange and the node, one of the worker node become the master and the master become the node? Is that possible? Okay, so you can add a computer, a new EC2 instance, and let that EC2 instance be a manager. Okay, you can make they can be existing two managers, but it is not possible for you to create a manager before you add. You add a node and then you make it to become a manager, and then you can also promote worker to become manager. Okay, promote worker 1 as a manager node. Okay, docker node promote worker 1. This command will make your worker 1 to become a manager node. Okay, and you can also demote it. Docker node demote worker 1. It is demoted. So you can promote a node to become worker node, manager node, and you can also demote that particular node. Okay, the reason why I'm going very, very fast with all this is that in the industry nobody uses Docker Swarm anymore. Okay, in the industry nobody uses Docker Swarm. All these things that I am showing you like this, we use but Kubernetes. Kubernetes is also another orchestration tool, and that's the next tool that we are going to be studying, which is Kubernetes. Docker Swarm is very primitive. See, I have shown you scaling, but the scaling does not occur automatically. You have to actually be running those commands in order to be scaling. Okay. Then there are so many things that Docker Swarm cannot do, which you are going to see Kubernetes is going to be performing all those things with a lot of ease. So Kubernetes is much more used in the industry more than Docker Swarm. They are going to always be asking you questions in the interview session. Why will you go for Kubernetes and not for Docker Swarm? What are the differences between Kubernetes and Docker Swarm? Okay, don't misinterpret Docker for Docker Swarm. Those are two different things. Docker is a containerized service. Docker Swarm is a service that orchestrates containers. While Docker containerized the container, Docker Swarm orchestrates the container. The the general logo for Docker Swarm is always a ship sailing in the sea. That means all the containers are like in a swarm. Okay, we have a situation of this manner where all the containers are in some sort of a swarm. You have a swarm like this, and then you have containers in that swarm, which means that all these containers that are in this swarm, they are serving one and the same purpose. All of them are serving one and the same purpose. This container is in a different computer. This one is in a different computer. This one is a different computer. All of them are in a different computer, but they are existing in a swarm. That means they are interlinked. All of them are interlinked. So you always see when they talk about Docker Swarm, you always see ship sailing in a swarm. Okay, that is what you will always be looking at. All right, I think did we complete our syllabus? Yes, we completed our syllabus. Okay, so in the absence of no questions, we'll meet on Wednesday. Is that?
Yes, sir.
All right, cool. I'm discovering that most of you, nobody has been able to watch the video for yesterday. And please make sure before Wednesday, the video for today and the one for Saturday has already been consumed. Okay, don't pile work, please. Don't pile work. All right.
Okay, sir.
All right. See you guys on
Okay,
Wednesday.
sir.
Good night to everybody.
Okay, sir.
Good night.
Good night.